Hey guys, wanted to go ahead and begin chapter 12. I know this particular worksheet says chapter 2. It's just because I'm using it out of a different book. Our book doesn't go into this as well as what we really need to. But again, I said this in the notes, but this is probably going to be one of the easiest pieces of work that you're going to be able to do. This should really be a grade booster. I would expect that probably everybody should be able to get at least 100 on this next test that we've got coming up. But this is just kind of a deeper dive into matrices. And again, I know this is a term probably you didn't even know before we started into Algebra 2. Maybe you did. But a matrix is singular, obviously, and matrices is plural of any kind of rectangular or square ordered array of numbers. So basically, it's just orders that are put, numbers that are put into an array of numbers or orders. And again, it says that each number in a matrix is called an element. A lot of this we've kind of already looked at. We kind of took a little bit of a look into this in our last chapter on systems. But again, I'm just highlighting some of the key things. You can read every piece of this if you want. It says when describing a matrix, always give the number of rows and then the number of columns. Okay, so if I'm describing this matrix right here that they're giving me, I have 2 rows and I have 3 columns, so it's a 2 by 3. Okay, so that's kind of the way you describe that particular matrix there. You always describe the rows first, and then you're going to talk about your columns. Okay, so one of the neat things, I guess, that it talks about here is that since their invention in 1858, matrices have played a role in such fields as economics, engineering, and quantum mechanics. And so one thing to think about if you're kind of a geek, I guess, and like computers, binary code is actually your computer. When you look at, for instance, this video that you're watching right now, it's converted into digital media. Well, binary code in computers is all just a bunch of zeros and ones. There's just in different orders, okay? So computers, literally, the programs they use are just a bunch of zeros and ones put in different orders. And so they use this a whole lot in computer programming. And so it really is a lot of useful things. If you get into those type fields, then you're going to be using matrices quite a bit. So what we're going to be focusing on really in this chapter is 2 things. We're going to be talking about actually a couple more than 2, but we're going to be talking about doing operations with matrices, adding, subtracting, multiplying. We won't be doing dividing, and I'll get into that later as to why we can't divide matrices. But we're also going to be doing some matrix equations as well as something called inverses and determinants. So several areas that are going to be involved in this, but we're going to start today with addition of matrices, and then we're going to talk about scalar multiplication as well. So a couple of notes we need to talk about when we're talking about addition of matrices, okay? A couple of key things that we need to pay attention to. In order to add matrices, they must be of the same size, okay? They have to be the same size. This is probably the most important thing on this page. So in other words, it says they need to have the same number of rows and columns. A 2 by 3 matrix can only be added to another 2 by 3 matrix. And so if the matrices have different dimensions, they can't be added together. Okay, and notice what it says. To add 2 matrices of the same size, just add the corresponding elements of the 2 matrices. So it's given us this little example here, and we'll also work one more as well besides this one. But you notice this is a 2 by 2, and this one is a 2 by 2. So immediately we know that we can add these 2 together because they have the same dimensions. So literally all you do is take, this is the first element of the first row, right? And you take the first element of the second matrices. So you take 7 plus a negative 6. 7 minus 6 really is what that is going to give us a 1. That's how they get this 1 right here in this corner. Okay. Then they take, and I'm going to use a different symbol, I guess. I'll use a kind of a rectangle. They take this element and they add it to this element. So negative 2 plus 2 is going to equal 0. That's how they come up with 0 right here. Okay. Now they're taking this element here, which again, this is the second row, first column. So second row, first column in this matrix, and second row, first column in this matrix would be negative 1 plus 4 gives us a positive 3. Boy, I'm running out of shapes like really, really fast. Okay, and then the last but certainly not least, we have this element here, which is 4. I don't know, I'll just make an oval of some sort. And that would be added to this element in this matrix. So 4 plus 0 just simply equals 4. So that's how we get this answer. And notice our answer is also a 2 by 2. So again, these dimensions have to be the same in order to be added together. And once you add them together, you should get exactly the same size or dimensions of a matrix. Okay? Now let's look at this one. And this is what I would encourage you to do right off the bat. The first thing is try to define what you have. Well, here I have 1, 2, 3 rows, 2 columns. So it's a 3 by 2. Okay? Now notice this one. This is 2 rows and 3 columns. So it's a 2 by 3. So now I'm going to ask you, can you add those two together? Well, the problem is you don't have corresponding parts, right? This 7 could correspond to the 6. This -2 could correspond to this 2. But now I've got a 2 just kind of hanging out here. And it doesn't have anybody to be partnered with. So this cannot be added together because they're 2 different dimensions. So in this case, you would just put NP, not possible. Okay? So it's exactly what you're going to do on your practice. And boy, your practice is really, really small today. You're welcome. Thank you. You're welcome. So we only have 6 problems that we need to do. And actually, we're going to work through the first one real quick together. So add the matrices together when possible. Notice your instructions. When the matrices cannot be added, write MP. So the first thing you're going to do is check your dimensions of each matrix. Well, this one is 2 rows, 2 columns. So it's a 2 by 2. This one is 2 rows and 2 columns. So it's a 2 by 2. So that tells me right away I can add these 2 matrices together. So 8 plus 0 is going to be 8. And again, this is going to make a 2 by 2. So I can go ahead and kind of draw that out. Then I can take 4 plus -7. 4 plus a -7 is going to give me a -3. Then I have 5 minus 4, or 5 plus a -4 is going to give me just a +1. And then -3 plus -9 is going to give me a -12. So there is my answer right there. And notice it is a 2 by 2. So the first thing you need to do for these other 5 questions, obviously you can just write this one down because we just did it. But these other ones, the first thing you need to do is look at the dimensions and make sure they're the same so that they can be added together, and literally just add them together. Now, I will tell you, you can do this on the matrix calculator. But to be quite honest with you, it would take you longer to type it into the matrix calculator than it would be just to add the matrices together, okay? So it's not really going to be that helpful for you in this particular part. Now, there is going to be at the end of this chapter, we're going to be using the matrix calculator quite a bit. So we'll talk about that when we get there. So now let's talk about multiplication of a matrix by a constant. Now, there's another name for this that you may see quite a bit in other publications or maybe even on ACT, and it's called scalar multiplication. See if I can spell multiplication. Hopefully I can. Scalar multiplication. So think about scaling something up or scaling something down, okay? It's really quite simple. And so I want to use an example here for you real quick. What if I had like 4 times the quantity x plus 2? What if I had 4 times the quantity x plus 2? Well, think about what I would do there. If I saw something like this, I would know that I need to distribute this 4 through, right? I need to multiply this 4 through every single term. So I would end up with 4 times x equals 4x, and 4 times +2 is +8. And this would be, I guess you could call the simplified version of this. Well, that's exactly what you do here with scalar multiplication. So let's look at this example real quick, and we'll not really look at this down here. This to me looks confusing. Okay, but all it's saying is I'm going to take this matrix. Let's call this matrix A just for fun. I'm going to take this matrix, which is matrix A, and I'm going to scale it up by a factor of 4. So in other words, I'm going to make it 4 times bigger than it is right now. So literally all you have to do is exactly what we've done over here. You're just going to multiply this 4 through every single term. So it's still going to end up being a 2 by 2, 2 rows, 2 columns, but the only difference is it's going to be 4 times bigger. So 4 times 1 is 4. 4 times 0 is 0. 4 times 3 is 12. And 4 times 4 is 16. That is your answer, literally. So all you're really doing is you're kind of doing the distributive property. All right, and they kind of spell this out a little bit differently than we did, but we got exactly the same answer. Okay, so what you're going to do is you're going to go ahead and do these other 6 problems that are down here at the bottom. Okay, and again, all you have to do is just multiply or distribute this -2, for example, in this problem, through every single term, and you've got it licked. So if you need any help or have any issues with this is it for today, guys. It's going to be pretty simple. Each of these sections are kind of small, so it shouldn't take you as long to do this. And again, hopefully you're going to learn something new. And these are some of those real quick problems that you can now be able to accomplish on the ACT and get you some extra questions. Thanks.